So hi everyone, welcome back to our daily LeetCode challenge series. So today is day 69 and today we are going to solve LeetCode problem 2996. A smallest missing integer greater than sequential prefix sum. Okay, so this is a easy level problem. So let's see the problem statement, then we'll talk about the solution part. Fine. So you are given a zero index array of integer nums. A prefix num 0 to I is sequential if for all I is less than j and j is less than equal to I. Nums of j is equal to num of j minus 1 plus 1. In particular, the prefix consists only of num of 0. It's sequential. Okay. Return the smallest integer x missing from num such that x is greater than or equal to the sum of the longest sequential prefix. Okay, so what basically we have to find the the integer which is equal to the sum of the sequential digits in the given array, whether it is present or not. If it is sum is present, then we have to say the nearest one which is missing. Okay, so example 1, we have the array 1 2 3 2 5. So here we can see like it is sequential and sum of this is 3 plus 2 plus 1 is 6, and within this array 6 is not present, so that's why we're getting 6. Okay, in case if 6 was present, then we have to check the next, so it will be 7, right? But here 6 itself is missing, so we are getting 6. Same explanation is given here. In example 2, we have 3 4 5 1 12 14 13. So here we have this 3 in the sequential in the order, so sum of this is 12. So here we can see 12 is already present, so next to 12 is 13 and that is also present. 14, that is also present, so next will be 15, so that is not present. So in that case we are getting 15, right? So the nearest one after the finding the sum of the sequential array sub array, that element should be present. Fine, same explanation is given here. Okay, so in the constant part we have given length of the array can be varies from 1 to 50 max. Fine, and number 5 will be also within 1 to 50 range, so that's comes under integer range. That's fine. So what we can do is so after sum we have to do the lookup in the array itself, and if an array can have duplicates as per the example we can see. So what we'll do, we'll create one hash set in order to remove the duplicates, and even we have some inbuilt function to directly check whether that number is present or not instead of iterating again over the array, right? So what we'll do, so we have the nums with us, so let's take length equals to nums dot length. Fine, now we'll create one hash set of integers, right? Let's say set equals to new hash set. Fine, now we'll do one for loop, and we'll just push whatever numbers we have into this set dot add. So like whatever duplicates, that will be get removed, so we don't have to iterate again to finding the sum of the array, right? Now we'll add set that add n into it. Fine, now we have the set with us with the unique elements. Now we have to find a sequence and their sum. So in order to do that, what I'll do, I'll take one variable as sum initializing with 0, right? And we'll iterate from index 1 by checking with the back forward. So I will going to apply this logic here. So starting from 0, it should go till length, and I'll do plus plus. Now here I'll check if nums of I, if it is equal to nums of I minus 1, right? I minus 1, even do plus 1 here. So we have to check if both value is equal or not in that scenario. So I'll make it one. So let's say Yeah, let's say we are at 2 and we are checking with previous one by adding 1, so both should be equal. That means it is in sequence, right? So this logic I am applying here to find the sequence. If it is so, what I'll do, I'll just add this value into our sum. So I'll add nums of I into this, I minus 1 thing. Yeah, if it is not so, then we'll simply break our loop. That means like we have find the longest subsequence, and we are just coming out of the loop because we have to find from the started prefix sum, right? Sequential prefix sum. So if it is whatever prefix we have the continuous, that one max we can take, right? Now after getting this all, what I'll do, will come out here. Then we have to check if our set contains, that's why I'm using a credit set, so we can use any inbuilt vendor, right? We'll check if sum is present or not. If it is so, what we'll do, we'll increase our sum with let's say we'll just do one increment, fine. If we found so, then we'll come out and we'll return that sum, right? So let's say in the first case we have got 6. If check 6 is present, it is not present, it just come out of this loop and return 6 itself. But let's say in this case 12 we have, it will increase 13 we have, 14 we have, now it will become 15. We'll check 15 is not present, then count of the loop and then return 15, right? Okay, so hope it will work now. Let's submit and see. So I think we have got some wrong answer for the scenarios. Okay, so my bad, like some initial sum we have to take num of 0 because we are starting from the starting sequential prefix we have to take, right? And here we have to take the ith value as well because here it is getting missed. That's where we're getting the lesser values in sum. Now submit and see. Hope it will pass now. So yeah, it both accepted. Now submit and see the test case as well. So yeah, all 616 test cases got passed, right? So yeah, if we talk about the time complexity here, so it is big of n because we are iterating once for each number here, right? And 2 loop is there, so fine, it is big of n. And space complexity, as we have using creating one set in order to track the elements, right? So it is also a big of n. If you know any optimal version of solution for this problem, then you can just comment it down. Yeah, so that's all for today. Let's see you next video. Bye.